In this video, I'm going to show you how you can move from a transaction log for a subscription business all the way to CLV. So here we have our usual transaction log format: date, customer ID, and spend. We can see that as we scroll down, all the spends are already kind of aggregated to the monthly unit of time. They're all happening at the beginning of the month. I've got another video that shows how you can aggregate to a unit of time if this is not the case, such that if you see the same customer making a purchase on the 1st of May and the 5th of May, that it can aggregate that together. But having a common unit of time is very convenient. So step number 1 is going to be to identify each customer's birthday. We can use that to then cohort the customers. So to get their birthday, we're going to create a column called init that represents whether or not a particular transaction represents that customer's first purchase. And what we're going to do is, to find that, we're going to first sort the data by customer ID and then by date. So you can see customer number 1 right now had retained his or her subscription through January 2019. We see this customer only stayed for a month and then churned. So it's kind of what we would expect. Now, because all the data is chronological, the first time I see a customer ID must have been the purchase that birthed that customer. And so we can kind of encode that logic by saying, if this is the first time I'm seeing this customer ID, I'm going to put a 1 in here, otherwise I'm going to put a 0. Copy that down, and so then the birthday is going to be equal to, if it's the initial purchase, so if this is equal to 1, it's going to be this date. Otherwise, it's going to be, we've already seen the birthday for that customer. So let me just kind of get this down over here. At date. Okay. So we can see for customer number 1, well, let's go to, what's the easiest way to show this? Let's go down over here. So you can see these customers, like customer number 3035, his or her first purchase was in March. And so we can see that's this customer's birthday. And obviously, this customer's birthday is going to be the same at any point in time, because you're born at one time. That's it. So yes, again, hopefully this should make sense. Now that I have the birthdays, I can create a pivot table. And what this is going to allow me to do is to get the empirical retention curve and to get the AOV trend. So I'm going to put date over here. I want the count of the customer IDs by date. And remember, I'm going to want to filter by birthday. Don't need this, don't need this, don't need this. So again, I'm going to get the empirical retention curve for this January cohort. And I'm going to get the average order value each period. So I do that by getting the average over here. So again, this is all looking right. But again, got a few different birthdays here. I'm going to filter to the January cohort. So you can see all the spends are 20. This is probably some very simple, plain vanilla business like GPT Plus. And we can see the customer IDs, the count of the customer IDs over here. So this cohort represents 987 people, and we can see, a bit over a year later, 394 of those customers remain. So we can use that to get our retention curve. So that's kind of step number 2. So we see over here, we've talked about the shifted beta geometric model. Let me just put shifted right up here. So we can use that to take this retention curve, use this to take these customer counts to get the retention curve and then fit the SBG to that. So I'm going to put this data in over here. The actual percent of the cohort that's alive is this. The expected percent of the cohort that's alive unconditionally is governed by this formula. Again, see the other video. To get the right parameters, I am going to get the standard error. Just delete that for now. Standard error. I'm going to get the squared error. Take that minus that. There we go. So then the sum of the squared error is going to be this. We're going to want to hit solver. We want to minimize the SSE by changing gamma delta. See how good our fit is. Good. Now the big question is, how far out do we project? I'm going to project out 5 years. So this will be a 5-year LTV. So I'm going to take this estimated percent alive, and I'm going to paste down like that. Then when you think about it, the thing that we're going to want to get is how much spend and then ultimately how much contribution profit and the present value of the contribution profit that we get each period. So spend while alive. And we know that this is, let me just kind of park that over here, 20 every period. So spend while alive historically is just this. These are the actuals. Now, we're going to want to project that into the future. Normally, this is where you use a regression model or something like that. I've shown that in another video. So see that video if you do have trending to spend. Otherwise, we can see here, it's probably safe to say we're going to expect 20 a month while customers remain alive. So this is just kind of making that assumption. So these are projections. So I'm just going to highlight these in red. Obviously, these are all projections, so I'm going to highlight these in red too. So the expected spend then is going to be the actual spend while alive multiplied by the proportion of the cohort that is alive. Now, we've already observed the first 12 months of data. So for the first 12 months, we are going to use the actual retention curve. But then starting in the 13th month, we don't have actual data. So we're going to take the projected AOV and we're going to multiply that by the expected proportion alive. Now, thankfully here you can see these lines are just right on top of each other. So not going to be a big difference whether we use the actuals and the expecteds, but in other data sets, you never know. So next is we're going to need the other things, the other ingredients that we need for CLV. So namely contribution margin, CAC, the annual WAC, and the monthly WAC. So if the contribution margin was 40% static all the way through, imagine that the CAC was 50, imagine that the WAC was 12%, then the monthly WAC would be that. So the expected contribution profit is just going to be this times contribution margin. And then the present value of the expected contribution profit would be, need a hard code. There we go. The present value is going to be this divided by 1 plus the monthly WAC. Make sure to hard code that one. There we go. So the PAV over the first 5 years is going to be sum of all this. We then subtract off the CAC of 50, and that gets us the CLV over the first 5 years. It's this. So the marketing return on investment, or CLV to CAC, is equal to this divided by this. 150%. So if these were your figures, you probably feel pretty good about this. I mean, it's not the biggest marketing return on investment I've ever seen, but yeah, it's not bad, especially if you're reasonably mature and uh, you're in paid channels. This is not kind of reflective of a very nascent business, then this would actually be quite good. But yeah, that's how you go from a transaction log all the way through to CLV. Again, a couple uh, simplifying features of the data, I would say. But I'd say that the extensions that we would need to move to the more complicated cases would be relatively easy to handle. Thanks so much.